Let me use my handphone to record for today's lesson. Okay, I want to go over the idea that we touched on yesterday on volume. Okay, so let us start with area. When I have a line, let's say my line is 1 cm. A line only got length, okay? But if I put 1 cm worth of all these lines together, 1 cm, then the way that we describe how big this piece of area is on the flat land, we call this area occupied an area. And how much area are there? There are 1 cm of 1 cm inside. That is why when we talk about area, we multiply the sides. So there are 1 cm long of 1 cm. We don't count by how many 1 cm are there. We don't count there are 1 cm, or there are 5 1 cm, there are 10 1 cm. Because 1 cm by itself got no thickness at all, got no width at all. So it is actually countless 1 cm. But how many 1 cm are there? We don't know by number, but we know there are 1 cm of 1 cm, which is why the area is 1 cm of 1 cm. So 1 times 1 is 1 cm times cm becomes squared centimeter. Okay, so that is to describe area. Then now you imagine if I put this 1 cm flat piece like a paper like that, I put it on the ground, 1 cm, 1 cm. So this is the square piece of paper if I put on the ground. Then if I keep stacking more and more pieces of paper, I stack the same size paper, keep stacking up, then it will start to occupy space. At first it is totally flat, but now becomes something solid, an object that I can hold. Then I keep stacking all this paper up. Then it will start to keep stacking up. So one layer like that, keep stacking up. Until I have this space. And how do I describe this space? Again, it is endless paper. It is endless layer of this area. Then we cannot count there are 3 areas, there are 5 areas inside. So we also describe this area as, let's say I have 1 cm high, 1 cm tall of all this paper. Then it will be the volume, the entire space that is occupied by this object is 1 cm of the area. Then the area by itself is 1 cm squared. So 1 cm of this area, every one piece is 1 cm squared. Every one piece, the area is 1 cm squared. So if I stack 1 cm of them together, my volume will be 1 cm of all these 1 cm squared of area. That is why I can describe the space occupied, the area occupied, as a centimeter cube. So now it has 3 dimensions. There is a length, there is a breadth, and then there is a height or a thickness. Now it becomes a solid object. Okay? So can see the relationship between the volume, area, and a length. When you only have length, you only have 1 line. When you have 2 lines together, it can form an area. Then when you put all the area together, you keep stacking the area up, it forms a space, a volume inside. So that is the relationship between length, area, and volume. Okay? Okay. With that understanding, we can try some questions. So, workbook Let's go to the earliest question under volume. Workbook page 73. Okay, remember when we started with area, they also had a similar question. They want you to convert area from meter square to cm square. Then now they want you to convert meter cube to centimeter cube. So what this means is, now Elijah, Zhen Xuan, now you started with an object that has 7 meter cubic area, meaning this space looks like this. Looks like the total space inside is made up of 7 cubic meter. Then you want to change it to centimeters. So we don't go into this object further. Let us instead take a look at another smaller one, cube. Every side is 1 meter. If I have a cube that is 1 meter on each side, the volume of this cube will be equal to 1 times 1 times 1 equals to 1 cubic meter. But at the same time, this same block that I have, if I don't write in meter, I write in cm. 1 meter is 100 cm. So the exact same block, if I write in cm, and I find the area, I find the volume. The volume will be 100 cm times 100 cm times 100 cm. cm. So these two are the same. So that is to say, if I want to convert every 1 meter cube to using cm cube as a unit, every 1 meter cube I want to convert to cm cube, I must multiply by 1 million. Okay, this idea is the same when we talk about area, conversion. 1 meter area is 1 meter square. But if we write it in cm square, every 1 meter is 100 cm. So here can be written as 100 cm, here can be written as 100 cm. So every 1 meter square is also equals to 100 cm times 100 cm equals to 10,000 cm square. When we did area, we also did this conversion. Every 1 meter square is 10,000 cm square. So now every 1 meter cube is equals to 1 million. Is it 1 million? Yeah, 1 million cm cube. Okay. So for me, I don't remember 1 meter cube is 1 million cm cube. Instead, let's say I see this question, then I know I am converting. Next time, you all two split up, don't sit together. I know I am converting meter to centimeter, then I will go back to the most basic. I will go and write down 1 meter is 100 cm. But now I am converting meter cube. So I cannot use this scale. This scale is for converting the length. Every 1 meter is 100 cm. But now I'm talking about volume, so I'm talking about meter cube. So I will go and cube my left and cube my right at the same time. Then I will have 1 meter cube is 100 times 100 times 100 cm cube. So every time I do this conversion myself, when I see this question, so I don't need to die remember 1 meter cube is 1 million cm cube. I just need to remember 1 meter is 100 cm. Then I can get the conversion of area, I can get the conversion of volume. When I do this, I want area, I square both sides. I want volume, I cube both sides. Then once I have this, I can do my substitution. Every 7 meter cube is 7 times of 1 meter cube. Then every 1 meter cube is 1 million cm cube. So the result will be 7 million cubic centimeter. Okay? So I only go and do this when I see I need to convert this. Then I don't need to die remember this. Or else there will be a lot of things to remember. But I don't like to remember things. So remember one, then get the volume one from the original one. Then part B is using the same conversion, meter cube to cubic centimeter. So I can also use the same conversion here. 0.2 meter cube is equal to 0.2 times 1 million cm cube. So equals to 200,000 cm cube. Yeah. All this can be done using your calculator. You cube your 100, you key this into your calculator, 100 cube, it will tell you this number. Then when you are doing the multiplication, once you know 1 meter cube is this, you use calculator 7 times this to get this answer. Similarly, key in calculator 0.2 times this to get this. Okay? Understand the conversion? Express each of the following in meter cube. So same, I am converting cm cube to meter cube. I go back to my original thing that I remember or I know. 1 meter is 100 cm. I want to cube, I want to convert, so I go and cube both sides. So 1 meter cube, 1 cube is 1, that's why 1 meter cube. Then it's 100 cube. So 100 times 100 times 100 cm cube. Then this time round, I want 600,000. So from 1 million, how do I get 600,000? You can go back to your ratio lah. 1 million hard to convert to 600,000, never mind, I divide both sides first. So every 1 cm cube is 1 over 1 million meter cube. After that, then I multiply 600,000, or it will be 600,000 divided by 1 million. .6 meter cube. Okay. So from meter cube to cm cube, I multiply 1 million. From cm cube to meter cube, I divide by 1 million. So I also don't need to die remember. As long as I remember the first one, I can get all this also. Then same, this one just divide by 1 million. Then you'll get your answer. Try, go and key calculator. Okay? Can Then we move on No. Done. Okay. Find the volume and surface area of each cube. So here we explain this word a bit. Cube. Cube. By definition, it means a object, squarish one, where all the sides are the same. Meaning, when they tell you it is a cube, every length is the same. This is 18. The square base, it is a square base, so this one will be 18 also. And then the height will be 18 also. That is the definition of a cube. So just now, the shape or the object that we generated is formed by, how you all want to see? Split up. Zheng Xuan come to the front, or Elijah go to the side. Now, move how you want to speak, or both move to be fair to both of you. There.
One in front of Ari.
2 tables in front of Ari. Behind Xuan Yuan that row. Yes. Can see the screen? Okay. So back to our definition of a cube means the base must be a square, and then the height that we stack up is the same as the side of the square. So the square here is like a square base, and then the amount of squares that we stack up will have the same dimension or same length as the square base. So the whole thing, you look from the side, you will also see a square. You look from the bottom, you will also see a square. You look from the front, you will see a square. You look from the top, you will see a square. That is a cube. Every side you see is a square. Okay? Let me don't use black first. So if I see from the front here is 18 centimeter by 18 centimeter, so I will see a square. If I see from the top, here is 18, here is 18, then the side here is also 18. So when I see from the top, the green color one I see will also be a square. Then if I see from the side, when I see from this direction, 18, 18, so I will also see a square. So for a cube, that means the solid object I see from top, bottom, side, they will all look like a square. That is the definition of a cube. Okay? When I see from the different direction. Then, how do we find the volume? the volume is how much space is inside. So how much space is inside? This square is being stacked 18 cm up. So the total volume is this amount of length times this amount of length times this amount of length. Then we'll be able to put out the whole volume. So the volume of cube is equals to 18 times 18 times 18. Then key calculator. Where is my calculator? 18 cube, 5832. We started with centimeter, so 18 times 18 times 18 are all centimeter. So it is, we are also cubing the centimeter. So the unit is in centimeter cube. So this is the volume. Then the next word that we have to be familiar with is total surface area. So right now, if you imagine we have a dice. Last time when we have just an area. Let me save this. When we have a flat area, then we talk about perimeter. Perimeter is the line that goes around the area. Okay? So now we have a 3-dimension object. If we want to measure what is boxing this thing up, we no longer measure it by length. We measure the area that is covering this object from all sides. So for a cube, it will include this top face that is covering the box, the front face that is covering the box, the side face that is covering the box, the bottom face that is covering the box, the back face that is covering the box, and this side. Okay? So there are 6 squares that are put together to cover the box. So the idea of total surface area is similar to perimeter. Perimeter encircles the area. Then the total surface area is the area that covers the entire object. Okay, so it is the outside of the object. And then the outside of the object, we don't measure by length, we don't measure by volume, we measure by the area. What is the surface area that is covering the box? Okay, so for example, this one have my here's the box. Okay, so imagine this is now the solid that is generated. This is the box. Then I want all the surface that is covering this box. It will include this surface. It will include this surface. Okay? It will include this surface. It will include this surface. And it will include this surface. And the last side, if this one is covered, there will be another surface here. So when we add up all these surface, it will be called the total surface area that is covering the box. So that is what we want to find when we talk about total surface area. Okay? Okay, so back to our question in our workbook. The total surface area is the total area that is covering all the faces. Meaning, there will be one from the front, one from the side, one from the top, one from the bottom, one from the left, one from behind. So all together, if I were to go and number, there will be one from the front, one from the right, one from the top, 3 already. Then from the left, this side I have 4. Then bottom, I got not enough color already. Bottom there is a 5, and behind there is a 6. So all together there are 6 sides to that box. If you play with dice, a 6-sided dice is exactly a cube. Then when we throw, it can be 1, 2, 3, 4, 5, 6. So a dice got 6 sides, a cube got 6 sides. So end of the day, we will have 6. The total surface area is adding up all these 6 sides. And for a cube, each side is 18 times 18. Then there are 6 of them. So there are 6 times of the square area. Or you can 18 times 18 plus 18 times 18 plus 18 times 18, because there are 6 of them. Or you can straight away 6 times 18 times 18. Okay, and because it is an area, we are talking about these flat things that are covering. The unit is not in cubic centimeter. When we measure area, it is in square centimeter. Okay, try 3B on your own. The idea is exactly the same, just that just now is 18 cm, this time is 0.4 meter. Okay? Calculation wise, working is the same, just that the unit come out will be different. Cm times cm times cm give me cm cube. If I take meter times meter times meter, it will give me meter cube. Try. Once you understand the idea, it is just keying in calculator, your calculator skills. Anyone need help? Put up your hand. Pencil! Why are you so sleepy? Then you have to work backward. Are you sleeping too late? Then work backward. Why are you sleeping so late? Done. Volume equals to 0.4 meter times 0.4 meter times 0.4 meter. So it is equals to 0.064 meter cube. And there are 6 square faces. So each of the square face each of the square face is 0.4 times 0.4. 0.4 times 0.4 will give me 1 square face. Then there are 6 square faces. So I 6 times this number of square faces. That will give me my final answer, which is 0.96, and the unit is meter square because it is area. Can? Not difficult, right? Okay, then we go to page 74. Question 4. Once you know the relationship between volume, know the relationship, you are able to work around using some simple algebraic manipulation. Okay, so this time round, they never give you a picture, they never give you an object. But you already know what a cube is, you know what a volume is. If you need something to help you visualize, you can go and draw it out a bit yourself. There is a cube. Then the volume of the cube is 125 cm cube. Find its total surface area. Okay, so in between, there are something that you need to find first, right? If I want to find total surface area, I want to find this area, I must know I know it's a square, but to find the area of a square, I need to know the side. Okay, so I need to know the side. Then what I'm given is the volume. So I need to be able to link what I know, the volume, to what I want to find. I want to find the side. So how did I get this volume? The volume is equals to, let's call this side x lah. Okay? Then my volume is equals to side times side times side. So my x multiplied by x multiplied by x will give me the volume. Then I can link my volume 125 is equals to x cubed. Okay, I move back to the last page. Then you see, actually there is no difference. I know that the volume is side times side times side. Volume is side times side times side. Then in this case, I started with knowing the side. Then I multiply together, then I know the volume. Then in the next question, this time round is, I start with not knowing the side. But I know it is still the same. Side times side times side will give me the volume. This time is the side that I don't know, is the volume that I know. So now I can use the volume to help me find back my side. So if I change their left and right first, because I like to have my unknown on the left. So x cubed is equals to 125. I want to solve for x, then I will know what is the side. So I want to go from x cubed to become x. Then I will know the side already. So how to go from x cubed to x? I need to cube root my x cubed. Then my x cubed will cancel with my cube root, then become x. Then because I want the left to be cube root, I must also do the same thing to the right. Then when I cube root 125, then I press calculator. Cube root 125 is something that my calculator can help me do. Then x is equals to 5. Okay? So I have found that when a cube has a volume of 125 cm cube, actually the side must be 5. This side must be 5. This side must be 5 also. Because cube all sides are the same. After I find x equals to 5, I can proceed to find the total surface area. Because now I know each side is 5, 1 square is 5 times 5, and the cube is made up of 6 times of the square. See, I started with cm, so this is still cm, area cm square. Follow? Okay, part B, I get you all started, then you all try. The total surface area of a cube is 294. So again, it's a cube. Meaning all the sides are the same. And the total surface area is made up of 6 of the squares. Each of the square, the area is x times x. Meaning x times x will give me 1 square. Then the total surface area is made up of 6 squares. So when 6 squares, 6 area make up 294, I can from there find out what is x, what is each side. By forming this equation, I can solve to find what is the length of each side. After I find the length of each side, then I can proceed to find volume. After I know x, I can find volume. Okay? Try, go. Amira, why your head on the table already? First period shouldn't be so tired. My endpoint is x. Sorry. For now, my endpoint is x. So how do I get from 6x squared to become x? Okay, for those of you who are still stuck, 6 times of x squared, 6 times x squared. Square is closer to x, according to your board mass. So whenever we want to remove all these 6, we want to remove the square, we go from the furthest one. Plus minus, we remove first. After we remove plus minus, we remove, multiply and divide. Then lastly, then we do this square. Then we remove the square. Okay? So between 6 and the square, I must remove the 6 first. How do I remove 6? 6 times x squared, I don't want the 6, I need to divide first. So when I divide both sides by 6, I will have 294 also must divide by 6. x squared is 49. If in your mental calculation you know your timetable very well, 7 times 7 is 49. So x must be 7, because 7 times 7 is 7 squared. 7 squared is 49 means x is 7. But if you don't know your timetable so well, step by step, I want to go from x squared to x, I will need to square root my x squared. Then because I want to square root my x squared, I must square root my 49. Then I can press calculator. Calculator help me do the job of square rooting to know my side is 7. So now I have this cube that all the sides are 7. If I want to find the volume, is the length times breadth times the height. 7 times 7. Can? Okay, today we will finish up cube and cuboid. Then tomorrow we will do prism. Then we are about done with chapter 11. Okay? Today's basic is very important. Once you understand today's basic, how the shape is generated into an object, then cuboid, prism, cylinder, all very easy one. Once your basic idea is there. Okay? Can? Okay, now we go to cuboid already. Just now, the word that we use is cube. C-U-B-E. Cube. So when it is a cube, it means all the sides are the same. It will come out very squarish. But then, now, when we have all the sides are different length, 40, 10, 30, as long as one of them is different, some sides of it will be a rectangle instead of a square, we call it a cuboid. That is the only difference. Cube must be all square. Okay, cuboid will be not all square. Cube, all the sides are squares. Cuboid, no need all square. Here you go. Okay? Maybe one of them is square, the others are rectangle. Or maybe two of them are square, one side is rectangle. Okay? So then it will be called a cuboid. So like here, this object here, if we look at the bottom is a rectangle, 40 cm by 10 cm. Okay? If we look from the front, this side is 30, so here is parallel, here is also 30. So from the front it is also a rectangle, 40, 30. It's a different size rectangle from the bottom. Okay? Then if we look from the right, if we look from this side, it is a rectangle with 10 and 30. Okay? So cuboid is just not a square. It has rectangular sides or sides with different lengths. Then rectangular surfaces on each side. So how do we find the volume? If you remember how we generated the cube, we put squares and then by how much height. So if we have a cuboid, the idea is still the same. We put rectangles and stack up 30 cm of the rectangles. So end of the day, my volume is still this bottom rectangle, length times breadth. I have a rectangle already, then I multiply, there are 30 cm of them. Okay, so 40 times 10 times 30. Length times breadth times the height. The bottom area is multiplied by a 30 centimeter length of height to get the final space of this object, this whole box. How much is inside this box? This amount is inside the box. So the volume is 12,000 centimeter cube. Okay, so one thing to take note of. Wow, all sleep already. Umaira, Nabila. One thing to take note of is your 40, your 10, they must be 90 degrees apart at the bottom. Then your 30 is 90 degrees to the 10. It is also 90 degrees to the 40. It's all in a, like your X, Y, and then now you have a Z. It's all 90 degrees. Okay? Then the total surface area. No difference, cuboid and cube. To form your cuboid, you still need the 6 faces. Top, bottom, front, behind, left, right. So your cuboid still has 6 faces. So you need to go and identify where the 6 faces are. So just now I mentioned from the front. If I see from the front, I will see this rectangle. This rectangle 40 cm by 30 cm. Then because it's rectangle, the front and the back will be the same one. Just like your parallelogram like that. The front surface, the back surface must be the same size. Okay? So the blue color one, I will have 4. I write in color also better. Okay, I will have 40 times 30 to get my blue color surface. 40 times 30 will give me my blue color surface. Then there are 2 times of this blue color surface. One at the front, one at the back. Okay? So there are 2 of them. One at the front, one at the back. Then, if I look from the right hand side, I will see this rectangle, green color one. The sides are 30 and 10. Why I have 2? Because from the right, I have this green one. From the left, this side, I also have the exact same amount of area. So there are 2 of them also. Just like my front and back, this is my left and right. So I covered front, back, left, right. I still have the top and the bottom. So if I see the bottom, then I will see a rectangle 40 times 10. This will form the bottom. And the bottom is the same as the top. Okay? So the last pair of area, the red color one will be 40 times 10 plus 40 times 10. Altogether there are 6 sides of them. Okay? You know the idea what is total surface area, you get the object, then you go and identify, then go and add them together. For cuboid, it will be 3 pairs of same area. Okay? So, when I really write, I can just write 2 times of 40 times 30 plus 2 times of 30 times 10 plus 2 times of 40 times 10. When I really write down or when I go and press calculator, I can add all these together also, 6 sides. But if I know these two are the same, these two are the same, these two are the same, I can write like that also. So either way is okay. You practice enough, then you will find which one you're more comfortable with, which one make you clearer for yourself, then you go and do that way. Then you may want to key in everything inside your calculator, one whole line, or for me, I very slow one. So I will key in this part, then I will write down. This part is 2,400. Then I will just key in calculator this part. Write a bit more, never mind one. At least it is easy to key in the calculator for me. Whatever that will make me make less mistake. Okay? Under standard. Understood? Understood? Okay, then try part B. This time round the bottom is a square, but then the height is not the same. So it's not a cube anymore. This is called a cuboid already. Try, find the volume, find the total surface area. Can? Anyone don't know how to start? Start. We do volume, length times breadth times the height, or just the sides. You can identify 0.5 times 0.5 times 4.2. volume, so cubic meter. Hey, you all should be doing, then just compare, just double check, not just waiting for the answer. Okay, volume, length times breadth of the base area, then we multiply by the 4.2. Okay, the base area multiplied by the height. Total surface area, there are 6 sides. The bottom is a square 0.5 times 0.5. Then the top is a square also. So 0.5 times 0.5, there are 2 of them. Then 0.5 times 4.2, 0.5 times 4.2. So this will take care of the front and the back. Then when I look at the side, this is also 4.2, this is also 0.5. So the left and the right will also be 0.5 and 4.2. So these two are exactly the same. So in the end, because the bottom is a square, the top and bottom is this dimension. The 4 sides at the side, because it's a square, so the 4 sides actually the same rectangle. So in the end, it is 4 times of 0.5 and 4.2. But either way, you add them up, you get 8.9. Yes. Can? Okay, 10 more minutes. Let's go. Why? I should take my camera, then upload this. But like that, you will be like shaming him publicly. Wait here. You know why they laughing or not? Huh? You have no idea what is going on in your surrounding. And why? Why are you not aware of the surrounding? What are you doing? That is why. Yeah. Should you be doing your iPad now? Then do you want me to take it away or you keep it yourself? Go, keep. You know when you are so engrossed, you are still biting your finger, don't know people looking at you. So be a bit more aware of the surroundings. Don't be totally sucked to your iPad controlling your life like that. Okay, 6A, B, C, D. You all please try on your own. Then we go on to look at question 10. More difficult. Don't want too difficult. We do question 8. 10 and 11, I think too difficult already. Usually exam also won't ask until, maybe will lah, question 10. Okay, a cuboid has length 8 cm, the width 6 cm, and the height 4 cm. Then they tell you the total surface area, then ask you to find x. So we have to work a bit backwards. What is the total surface area? Then we go and equate it to 948, then we will be able to find x. So if just using my dimension here, what is my total surface area? I will have a bottom. The bottom is formed by x and 6. Okay? So again, if I don't know how to visualize, I can go and add these lines myself. This is like that. So there is a bottom rectangle. The bottom rectangle is the same as the top rectangle. Then if I see from the right, I have a 4 times 6. Then if from the left is also the same 4 times 6. Then I see from the front, it will be a x times 4. And the back will be same, x times 4. So altogether there are 6 sides. If I go and add up these 6 sides, the top and the bottom is x times 6. Then I have top and bottom, so I have 2 of them. Then the front and the back, I will have 4 times x. The front, 4 times x. Then I have front and the back, so I also have 2 of them. Then I have the left and the right. Left and right are 4 times 6. And also 2 of them. Okay, so simplify. 6 times x is 6x. 6x times 2. So 2 times. Recently I keep making careless mistake. Too old already. Two times 6 is 12. 2 times 4 is 8. 2 times 24 is 48. Then I can simplify. 12x plus 8x is 20x. So this is my total surface area. So my total surface area is, oh, Lucas very happy, 20x plus 48. But at the same time, they also tell me total surface area is 948. So meaning, this 20x plus 48 is the total surface area. The total surface area is also 948. So I can equate them. Then I want to find x, means I want to make x the subject. So I must first remove the furthest away one. Plus minus are the furthest. So the 48 remove first. 20 times x, keep with x first. So minus 48 on both sides. 48 minus 48 becomes 0. Then the right hand side I also must minus 48. So if 20x is 900, I want 1x, I don't want 20x, I need to divide both sides by 20. Can okay, I have 2-3 minutes left. So we go and touch on another shape that we are going to start next lesson. We have, hey, this part important. We have started with a square, then we stack these squares up until we have a cube. Then when we look at cuboid, it is actually rectangle, then we stack up the rectangles until we have a cuboid. Okay? So now, if my bottom is not a square, it is not a rectangle, if I stack triangles, can I stack triangles or not? I still same. I have this area of triangle, then I keep stacking these triangles up. I will also form a solid object. Okay? So there is still a base area. I still multiply by the height, then I will get a solid object. In this case, it will look like a the ends are all triangles. Then I stack the number of triangles up, become like a Toblerone like that. If you can imagine. Okay? If I don't stack triangle, if I stack pentagon, can I stack pentagon? I can also stack pentagon. Okay? Then all these, not square, not rectangle one, we call all these 1, 2, 3, we call them with a common name called the prism. Okay? So actually it is not much different from cube and cuboid, just that the ends can be of different shape. It can be a star shape also. Then we still call it a prism. Okay? Then, okay, next lesson then we go into more detail about prisms.